This Arduino Uno is coupled with our solderless breadboard where we've set up the circuit from previously. It's also got some other stuff on here that we're not going to use for anything. Now we've set up this previous circuit so that we can measure the temperature on this TMP36. And the output of that is attached to this green wire, which is running over here to pin A0 that we're going to read later on. The output of the push button, which is normally low but is high if it's pushed, is being led over here to pin 10 so that we can read that in, again under program control. And finally, I'm checking the difference between ground and the analog reference pin here with my multimeter. And right now this Arduino Uno is running on the internal voltage reference for analog conversion, and it's giving us a value of about 1.08 volts. It should be nominally 1.1 volts, so that's really close. But by measuring it, I get a more accurate value for that I can use in doing my voltage conversions. Finally, let's note that it is about 25 degrees here, at least measured on this thermometer. I have no reason to believe that this is any more accurate than my TMP36, but it does provide some confirmation that the values we'll get make some sense. This is the code I wrote in the Arduino IDE to take some data from this TMP36 with the push button to control it. So I've got my setup code here. This is stuff that's going to run only once at the beginning of the program or every time we press the reset button. It starts by setting up the serial port to 115,200 baud. That's about 12,000 characters per second, so that's pretty fast for the output. Then it makes sure that the pins I want to use are set to the right directions. So it's setting up pin 13 to be output. That means we can write values out to it. And pin number 10, another digital pin, to be input. And that's where we're going to read the input from our push button. And for now we'll ignore this because it's all commented out. When we get to the loop function here, that's the function that it's going to call repeatedly, so this is going to run over and over again. We've got a variable called last print, which we're setting up equal to 0 to start off with, that we're going to use to keep track of when we last printed out some data. And because I'm making it a static variable, that means it'll remember the value from one call of the loop to the next call of the loop to the next call of the loop. And I'm making it an unsigned long, a 32-bit variable, so that it'll fit the value that's returned by the micros function. And then now that I've defined it, I'm going to figure out what time it is now and put that in this t variable. So if I can compare t to when we last printed, that'll tell me whether it's time to print again. I'm reading in a value from analog port A0 and putting it in the variable A. I'm reading in a value from the digital port, pin 10, and putting it in variable B. I'm converting the analog value into a voltage value. So if I take the analog value, which is a number between 0 and 1023, add a half to allow for the best estimate of what the range is, and divide by 1024, that'll give me the fraction on the scale. And then if I multiply it by the default voltage reference value, which I actually measured on my Arduino to be 4.945 volts, not exactly 5 volts, then that should give me a voltage that I'm reading in from the analog port. I can convert that voltage into a temperature using the information I've got from the data sheet. If I take the voltage and subtract off half a volt, that'll get me down to a 0 base value corresponding to 0 degrees C. And then multiplying by 100 allows for the fact that there'll be a 10 millivolt increase for each degree Celsius increase. So this should give me a temperature in degrees Celsius. Finally, if I've pushed the button and B is high, then I'll print a bunch of stuff. Or if the time that I started up here minus the last time I printed is greater than 1,000,000, so about every second, then I'll also print. So it'll go slowly, or it'll go as fast as it can if I've pushed the button. I'll make sure to record that I'm printing at this time, and then I'm going to print out some values. I'll print out the time, and I'm going to convert the microseconds time into actual seconds so that it's easier to see what's going on. And by putting a 4 here, I'm going to make sure that I print out to 4 decimal places. Put in a comma, I'll print the analog value, I'll print the voltage value and the temperature value. And finally, I'm going to put a new line on right at the end. Rather than using, say, print ln here, if I keep this new line separate, if I add some additional print in here, I'm less likely to get the line breaking in the wrong place. Finally, down at the bottom here, I'm going to blink the LED on and off. So if I read from pin 13, I can know what I last wrote to it. If it's high, then I'll make it low. If it's not high, then I'll make it high. So it'll blink back and forth every time we go through this loop. Now I'll go compile the code and upload it. And it says it's done uploading. And now I'll check and see what we get out on the serial monitor. So it does a reset. And then we start getting some values. So there's the time in seconds, the analog value, a value between 0 and 1023. This is the voltage it converts into, about 3/4 of a volt, or 750 millivolts. Now 500 millivolts, or half a volt, is 0 degrees Celsius, and it's 10 millivolts per volt, or sorry, per degree Celsius. So I know that this 750 millivolts corresponds to about 250 millivolts higher, or about 25 degrees above 0. And sure enough, my equation that I use to calculate the temperature shows me values of 25 degrees, near enough. And sometimes it says 25 and change, sometimes it says 24 and a bit. And it doesn't seem to have anything in between those. This is just going back and forth between 154 and 155. So it looks like the temperature resolution that we've got here, once we do our calculation, is only about half a degree. We might like to get better than that. I'll get back to that in a minute. Now I'm going to push the button, and the data comes in much more quickly. And then I'll stop, and it goes more slowly so that we can see what's going on. Now, if we're only getting about half of a degree resolution, we might want to measure on a more fine-grained scale, a higher resolution scale. And the Arduino Uno has an internal reference, which is a 1.1 volt reference. So if I change my code to tell it to use the internal analog reference by taking the comments off, and then I go down here and I change my voltage calculation to use a different reference voltage, and this is also the reference voltage that I measured from my particular Arduino for what it's got as a 1.1 volt reference. It's not quite exactly 1.1 volts. Then I can run the code again. And it starts up. And I'm getting the same kind of behavior, but now, where I was getting about 150 something before, I'm getting 700 and something. So I'm using a much more compact range. When I convert that to voltage, I get about the same value, somewhere in the 750 millivolt range. But you'll notice, as I go from 713 to 712, I'm seeing a change of only about a millivolt, or a change of only about 1/10 of a degree Celsius. So instead of having half a degree, I'm down to about 1/10 of a degree. I've got higher resolution measurement. And when I push the button, again, it takes data really quickly. So let's get some of that data and use it to make some measurements or make some analysis in our system. So I'm going to push the button here. I'll take a whole lot of data, And then I'm going to turn off the auto scroll so that it doesn't keep running up. And I'll take a whole lot of that high-speed data going back for about 10 seconds. This is really tedious trying to grab all of this stuff. Is there a better way we could do it? I'm going to press Control A, or on a Mac, Command A. And I'll copy that by pressing Command C. And then I should be able to paste that into a CSV file. So here I've got an Excel workbook, and I'll press Command V to paste all that data in. It's looking kind of ugly. It's put it all in just the one column, column A here. So I'm going to have to convert that. I'm going to go Data, Text to Columns, and I want delimited data, and I'm going to delimit it with commas. And now it shows me that it's going to split it into columns like that. And I'll say, okay, I'm finished. So now I've got the data all in columns. And I could plot a graph of that data. So if I take these 4 columns and choose Insert, that's a line plot. I don't want a line plot. I want a scatter plot. Scatter with data points. Then I wind up with a whole lot of data. I've got most of this data up here is the 700s, these analog values. And down here I've got the temperature data and the voltage data. Well, we're mostly interested just in temperature, so I'm going to delete those 2 columns. And now we've got the temperature data, and we can see here we've got a whole lot of measurements, about 1 every second. And then we've got these 2 bursts that we took very quickly over a period around 40 seconds and around 60 seconds. And finally, some more data that was just running along. So we got a whole lot of data there that we can process. And we're going to tackle that data either in Excel or in a Jupyter Notebook.